This is section 4.1, nonlinear functions and their graphs, and these are the topics we'll be covering here. Let's first define what a polynomial function is. A polynomial function of degree n and variable x can be represented by this. This looks really ugly. All we do is we have n plus 1 terms typically. Our degree is the exponent of the highest degree term. And these an's, or an minus 1, these ak's, these are just our coefficients. Okay? So this could be 3x cubed plus 4x squared plus 2x minus 1, something like that. They're all just written in this form. We use these subscripts because we could run out of letters if we use different letterings. All we're saying is each one of these ak's is a coefficient. This n is the degree. For degree 1, we already learned that was a linear function, and anything greater than 2 is considered nonlinear. So let's talk about the behavior of polynomial functions. A lot of times when we see a polynomial function, it typically has a peak or a valley. Notice this graph. Notice we have two peaks. Here are peaks, and here are valleys. Okay. We have terms for our peaks. Our peaks are called maximums. We divide our maximums into two categories. We have what's called an absolute maximum. In other words, that's the highest point on the graph. Notice the way this graph is shaped. There is the absolute highest point, which occurs over here at negative 1.94 comma 4.81. That's the absolute highest point. Now this is also a peak, but it's not an absolute maximum. It's not the highest peak. It's what's simply called a local maximum. It's higher than any other point around itself. This valley here we call valleys minimums. So hence this again is a local minimum. Some of you may say, well, it's the lowest valley. Yes, it's the lowest valley, but notice how this graph goes down on each side. It's not the lowest point on the graph, so we cannot call it an absolute minimum. Now these maximum and minimum are categorized into, are all part of what's called extrema. Extrema are either local or absolute. In this case, notice we have two maximums. In this case, they're both absolute maximums. Okay, but notice the absolute maximums have different x values, but the same y value. They both go up the same height. In this case, we have a local minimum or a local extremum. Now, if we want to get very technical about it, then we can sit there and say f of c is an absolute maximum if f of c is greater than f of x for all x in the domain of f. In other words, f of c is my highest point. There's no other point that's higher than f of c. Similarly, it's an absolute minimum if f of c is the lowest point for all points in the domain. We can define our local max to be f of c is greater than f of x for all x near c. So if I just look at a neighborhood kind of like around that point, like we come back to our graph, this is a local minimum here because around this point, it's the lowest point around. But if we go further away, it may not be the lowest point. Like down here is a lower point. So this is just a local extrema. Now the nice thing about polynomial functions is sometimes we see patterns develop. We see something called symmetry. This is an example of symmetry around the y-axis. Notice that if I take the y-axis and cut these graphs in half, the left half is a mirror image of the right half. And this is a property of what's called an even function. For an even function, f of negative x equals f of x for every x in the domain of f. In other words, if I plug in a negative number or its opposite, the positive number, you'll get the same y value. Notice over here at x equals 2 and x equals negative 2, there's my x and my negative x. The y values are both the same on this graph. Similarly here, the y values are both the same. Notice I have two different functions here. There's a red function and then there's a purple function. Both of these are considered even functions because they're symmetrical with respect to the y-axis. Now, we can also have things that are symmetrical with respect to the origin. Notice on this graph, if I just simply fix my finger on this origin and rotate it 180 degrees, I wind up with the same graph. In other words, I just rotate it left or right, I get the exact same graph. In this case, this is what's called an odd function. In this case, f of negative x equals negative f of x. So if I sit there and pull out 1 as my x, f of 1 is negative 1, f of negative 1 is 1, so therefore they're opposites. Now, how can you determine if a function's even or odd simply by looking at the equation? Well, for even functions, all the exponents of the variables are even. So in this case, f of x equals x squared. I only have one variable, it's 2. It's even. So this is an even function. This next function, g of x, is x to the fourth plus 5x squared. Even exponent, they're both even. So it is an even function. Here, this is x to the 10th plus x to the 4th plus 9. Notice 9 looks a little bit odd. You're sitting there going, well, the exponent of 9 is 1. That's odd. However, when we're talking about exponents, we're just talking about exponents of the variable terms. There is no variable term here. It's just 9. It's understood to be 9 times x to the 0 power, because anything to the 0 power is 1. So this 9 behaves as an even term. Similarly, for odd functions, we look at the exponents and they all have to be odd. In this case, f of x equals x. This is x to the first. That's an odd function. This one is g of x is x to the fifth plus 4x cubed. The 5 and the 3 are both odd, so this entire thing is an odd function. Finally, h of x equals x to the 7th plus x to the 5th plus x to the 1st. 7, 5, and 1 are all odd, so this is an odd function. Now, you'd occasionally get polynomials which are neither even or odd, and those that have a mixture of even and odd exponents. For example, f of x is x squared minus 5x. This is degree 2, this is degree 1, so it's neither even nor odd. G of x is x to the 5th plus 4x squared. Again, here's an odd, here's an even, so it's neither. H of x is x to the 7th plus x to the 5th plus 5. Remember, 5 is considered even, so I have two odds and an even, which means it is neither.